Morning, everyone. My name is Jordan, and today I'll be talking about AMD's 3D V-cache. So first, we need to understand what is caching in the CPU. Caching is a small, high-speed volatile area located on the CPU chip. It stores the frequently accessed data and instructions sent from the RAM. It is much faster than RAM, often 10 to 100 times faster. The trade-off for the speed is that the size of cache is way smaller, usually measured in kilobytes or megabytes, compared to RAM being measured in gigabytes. But there are different types of cache. As shown by my image here, there are 3 levels of cache. First level, L1, is located closest to the CPU cores. It is very small in size, commonly only 64 kilobytes, and this is usually split into separate instruction and data caches. But this is extremely fast and has the lowest latency, especially because of its proximity to the CPU cores. And L1 cache stores the most frequently used data and instructions specific to its CPU core. Then we have L2 cache, which is slightly larger than L1 cache, where L1 is usually in, around 64 kilobytes. Modern L2 caches are measured in megabytes, while some high-end processors can have up to 32 megabytes of L2 cache. It's more common for it to be 6 to 12 megabytes divided among the CPU cores. It is slower than L1 cache, but it is still much faster than RAM. And this cache is used to help reduce the load on the L1 cache. Then we have L3 cache. It is the largest of all, often over 32 megabytes, shared across all the cores. Rather than being embedded within each core, it is shared across all of the cores. It is far slower than L1 and L2, but it is still faster than RAM. The introduction of L3 cache reduces the chance of what is called a cache miss, which is when the CPU fails to find data in cache memory and must request it from system memory, that being the RAM. L3 cache used to be found on a separate chip on the motherboard, but modern architecture places it straight on the CPU chip. So the rate at which technology grows is exponential. As we know in our industry. And thus, there's an exponential demand for faster CPUs as well. For example, in gaming, most modern video games demand higher performance CPUs for realistic graphics and responsive gameplay. In content creation, they require more power for video editing, rendering, and 3D modeling. Even in AI and machine learning, more complex training models require higher CPU power. And then for multitasking, we're all guilty of having like 4 code editors open, 12 browser tabs, and Teams, etc., etc. There are challenges in scaling CPU performance, though. Traditionally, you would increase CPU performance through increasing its clock speed, but this faces diminishing returns due to power and heat constraints. And as CPUs become faster, memory access still becomes a bottleneck. And it's important to balance the performance gains with energy efficiency, especially with mobile devices. We don't want our phones to blow up in our pockets, for example. Introducing AMD's 3D V-cache. 3D V-cache involves stacking an additional layer of cache vertically on the CPU die, increasing the cache capacity overall. Where traditional cache is spread out horizontally across the CPU die, 3D V-cache stacks vertically, which allows for more cache to be added in the same physical footprint. This offers a substantial increase in cache capacity, reducing the chances of what is called the cache miss, and thus reducing the need to fetch data from RAM. This enables faster data access and reduced latency, resulting in improved overall performance. So this is a benchmark straight from AMD's website, comparing Ryzen 7 5800X3D, which is the first CPU they made that uses 3D V-cache. They compare it to an equivalent AMD processor with the same clock speed. And overall, it shows a 15% increase in performance for gaming. Even Intel's Core i9 processors, it shows greater performance compared to that. So in conclusion, AMD's 3D V-cache is a means of increasing the CPU cache by stacking the cache vertically. This increases the overall performance at an affordable price while retaining energy efficiency. Thank you very much.